I think the promise of data science in general is that it will lead us to better decisions than humans would make, or at least will lead us to equally good decisions, but at scale. However, making good on that promise is only partially a technical problem. I was a cultural anthropologist before I was a data scientist, so I tend to look at that full chain of human interactions required to put any kind of technical solution into practice. And when you look at things that way, data science does not have an awesome track record. Depending on whose estimates you look at, between 70 and 90% of machine learning projects don't make it to production. Don't add business value. And now as a data scientist, I look at that and say, well, there's all these reasons why that's the case, and that's actually not a particularly accurate number because some of them are stepping stones to later things. But the fact is the people who own the budgets that pay for data science teams don't feel that most projects actually add value. And it's not that the models weren't good, and it's not that the pipelines didn't work like they were supposed to. It's that the business, in most cases, wasn't willing or able to shift the basis of its decision-making, because making decisions on the basis of a model output is different than the way most enterprises make decisions. I'm going to focus today on those companies, enterprises, that are not first and foremost engineering teams. There are some enterprises that are engineering first. That is a different ballgame in my experience. I'm talking about all of the other companies that are first and foremost something else, and they have an engineering team and a data science team. So I've been working on the problem of data science adoption my entire career, and the company I co-founded is an attempt to address some of those issues. So really quickly, this talk isn't about my company, but I want to give a little bit of context so you can understand where the examples I'm going to use are coming from. AMP is an agentic CDP. I'm going to talk more about what that means in a little bit. We started as a global team. I have one co-founder in Paris, one in Singapore. I'm in North Carolina. And our first customers were consumer apps operating in Southeast Asia and India. One of our very first customers was a super app in Southeast Asia. We deployed for them in 8 different markets in the region, messaging in over 10 languages. We've been working on making the entire app experience more profitable to companies by making it less annoying to users. In fact, I believe Brent talked about this in the last talk. You've undoubtedly experienced pushy push notifications, emails you didn't want, annoyances. Apps are desperately reaching out to their users, and that desperation shows. And so we've been, because of that, with that context, I'm going to talk today about a reinforcement learning architecture we've built that has allowed our customers to accomplish the goal of bugging their users less, and therefore getting better return on their data science initiatives. So there are tons of apps out there. Estimates for Q1 of this year, about 38 billion app downloads, around $32 billion consumer dollars spent on apps. And all those apps of any appreciable size have CRM teams, because the biggest problem an app faces is the problem of attention. It's not a problem of user acquisition, because user acquisition doesn't really exist anymore the way it used to. There are robust systems out there for acquiring users, for getting them to download your app, to sign up. And there's issues of those may be performing worse than they used to, but those systems at least exist. But the real problem is that even when a user has your app on their phone, every other app in every part of their life is constantly competing for their attention. Having the app, being a user, having been acquired, doesn't really mean very much to a company's bottom line anymore. It's simply a first step, and not even a particularly important one in many cases. This is a known problem. Everyone I've talked to in this space recognizes this is a problem. The problem has a standard industry solution, and the solution sucks. And it doesn't need to. So that's what I want to talk about, not only because it's a pressing business problem for my own company, but because it speaks, I believe, to the way data science gets integrated into business decision-making in enterprises going forward. So the big challenge behind solving this attention problem is what I call decision connectivity, or lack thereof. Businesses have a lot of different data sources. That has to be made available to data science and analytics teams. They have to then process it, integrate it, unify it. I'll use whatever verbs you want to make it available for decision making. And then that has to get pushed out to whichever communication surfaces the company wants to use to reach out to their users. So to pick a very simple example, you may take website visits, mobile events in order to find out the last time they were on your app. You might take your point of sale systems to get some kind of value of expected LTV. And then you combine that together into some kind of high value active user segment. And then that gets pushed out to decide that those people are going to receive a particular push notification the company decided wanted. This process is full of bottlenecks. In order to get that data available, you need engineering capacity. In order to get the metrics or models that you're going to use to make the decision, you need data science capacity. In order to push them out to the teams that are actually going to action it, you have to use operations and strategic bandwidth. And then to actually get the thing sent, you got to use your CRM or product team. Each of those teams already have more on their plate than what they can handle. And so each of these points is a friction point that will take even a good system and grind it to a halt. So this is the old saw about garbage in, garbage out. The technical sophistication of how we process data is only part of what goes into a business decision. The real lack of sophistication, the garbage in most companies, isn't in how they move data, but in how they decide what data deserves to be moved. It's not the quality of the answers they're getting from their technical systems, it's how they decide what questions to ask. That's where the process is getting filled with noise, and the good data science work is getting buried under this cruft of institutional inertia. So I want to focus on one example because it's one that I'm familiar with and what the companies I'm working with right now. There are a lot of tools out there for getting messages in front of users. Those marketing and CRM tools, they operate on the basis of static segments and rules. To send a message, you have to tell the tool what segment of users you want to message. You have to bring that information to the tool and tell it that that's your definition. If you're going to send a general message, you have to tell it what day and what time you're going to send it. If it's going to be a triggered message, something that happens after, say, they abandon a cart, you have to tell it how long after they added to cart constitutes an abandoned cart. You have to put all of this information in. All of those questions that these tools need answered in order to just perform their basic functionality of sending a message are the questions that the teams who use these tools don't know how to answer. The standard tool set expects you to already know the who, where, when, what, why. The tools don't solve that. So, every single one of these tools has A/B testing capability. Everyone. I've talked to many, many companies over the last several years. I can count on one hand, maybe two hands, the number of companies that regularly use the A/B testing capabilities. They have the capability. It's right there in the tool. But they're not using it because they can't figure out what to test. They can't figure out who they should test on. If they, God forbid, have multiple teams who want to run their tests at the same time, or they have a single team that wants to run multiple tests at the same time. They don't know how to resolve the traffic jam that they fear, rightfully so, is going to result in a bad user experience. And so they don't test very often. Figuring out all of those decisions to just use the capability at their fingertips is too much. It's overwhelming. So they don't do it. So this is a problem of decision paralysis. There's too many users with too many unique needs and constraints for a rules engine and a dedicated human team to effectively manage communication. It's simply not a tractable problem, given that many parts of our technical systems are actually made of flesh and blood. So this is especially true as users are increasingly demanding authenticity and personalization in their experiences with apps. What we need is a system that can take an arbitrary set of data sources, an ETL process, machine learning models, metrics, anything that you think is important, then actually proactively make the necessary decisions to outreach to users, not waiting for a human to do that. I've taken recently to calling this an agentic CDP, a customer data platform, is usually the term for the place where you put all of the data and analysis that will be used for decision making. The step of an agentic CDP is that making those decision points available is not enough for the decision to happen. You have to have a system that's capable of acting on its own to actually make the decision. So there's a lot of pieces of this. I'm not going to go into most of the details because we don't have time. I'm happy to talk about them after. But besides just the time constraints, what I want to focus on today is the architectural problem. Any system is going to have buckets of work that need to be done, boxes that need to be checked. And those boxes can be checked with a lot of different tools. There are many different models parameterized in different ways that could meet these needs. In building AMP over the last several years, we have focused on defining what those boxes are and filling them as quickly as possible. I built most of those algorithms. I can promise you they are not optimized. That's on purpose because the architecture was more important, defining the architecture was more important to us than the specific optimization of pieces of that architecture. So I'm going to talk about some of the ways we have done this, but these are not the best ways. These are the boxes that need to be filled. So every user gets an agent. Every user has a programmatic agent that will follow them and be with them and learn what they like. And these agents can talk to one another. In order to get an agent that can make good decisions about an individual user, they need to take all of this information, all of the stuff about stuff that the user has done on the platform, as well as all the stuff that you are doing with that user, all the things you're sending out to them, and needs to combine them into 4 basic capabilities. I'm calling them surrogates, embeddings, edges, and weights. They could be called other things. Those work for me right now. So, surrogates. The agent needs a way of anticipating behavior. It's not enough to optimize on a discrete outcome of, I want conversions, therefore, that's the thing that I'm going to have as my positive class. Every business we work with has multiple objectives, and as was pointed out in the last talk, a lot of those objectives operate on very different timescales. So you need a way of turning all of those different objectives into comparable values that can then be combined into a single measure of how the model is going to not just determine success, but determine whether the user is headed towards success. You might send a message, and yes, you would love to get them to buy something every single time you send a message. That's obviously not going to happen. But you can find early indicators of that success, whether it's buying, whether it's adding to cart, watching a video, or retaining month over month. So, yes, I'll leave that for right now. Differentiation. the agents need a way of being able to determine how similar users are to other users. So this is a matter of creating embeddings. There are behavioral embeddings, ways of reducing the dimensionality of everything the users have done in the past, both short-term and long-term. Message embeddings, reflecting the amount of different messages you've sent and what kinds. I will talk more about that in a second. But this serves two purposes. One, these embeddings serve as a measure of baseline behavior, which is necessary at a later step that I'll talk about in a second. But they also allow you to find control users, users who could have been sent a message but weren't, but are very similar to a particular user who was sent a message. Those controls allow you to start getting, and there's a lot, causal estimates is a loaded term, but it allows you to start getting at a measure of an estimate of how much you can influence behavior, not just how much you can predict it. Messaging optimization is super risky. If you go on Netflix, there's never a time when Netflix says, we've decided not to show you any videos today. But that's the choice you make every time you message a user. You don't have to message them, and not messaging them could actually be a better choice if messaging them is going to bug them enough that they are going to turn off that channel for you to be able to access them because they're so sick of hearing from you. So that's why we need those control users. So we can estimate the impact of doing nothing. So we can then estimate the benefit of doing something and doing a particular something. Optionality. Part of this is just a basic recommender system. If you have inventory, you need to be able to tie inventory together. They've viewed certain products, interacted with certain products. What would be a next good product to send to them? Inventory isn't enough if you're messaging. You cannot send someone the same message over and over, even if it worked really well last time you sent them, especially if it worked really well. They will remember. And so, in addition to having a product inventory, you need to have a message inventory, modularized. So messages can be split into pieces, value propositions, calls to action, statements of the offering. These need to be tied together. So when you find a message that works well, you can find out what the ingredients of that message were, and then pick another message with different words that have similar ingredients. This is something that a lot of companies are already doing. It's one of the reasons Netflix has so many tags and why they spend so many resources managing those tags. Spotify, I believe, does something similar. It's one of the reasons why they have over 6,000 genres. There are not 6,000 music genres, but these tags, these labels, act as repositories for preferences. Once you are able to tag a piece of content with that label, you are then able to aggregate performance of content that was attached to that label, and therefore use that to make subsequent decisions the same way you would in any kind of a recommender system. In the end, what you have is timing decisions. This is day of week, time of day. It could be more specific like holidays, things like that, as potential actions in your action space. You also have copy actions, again, things like value proposition or statement of the offering. Each of these things get assigned weights. I'll talk about the weights in just a second. How much time do I have, by the way?
10 or 20 more minutes.
Awesome. Okay. So these weights can then serve as the agent's memory of which decisions are optimal for which individual user. And these weights can also be shared, basically averaged, across agents in order for agents who do not have very much information on their assigned user to then take lessons learned from agents who have more active users. So figuring out how to distill that memory is, in principle, very similar to Thompson sampling. I mean, don't imagine, it's what we do. So a model that uses only those embeddings, only that latent space to predict the outcome. That's the prediction of someone doing something. Sorry, I lost track of my notes for a second. Yeah, no, I had it. It was my brain, not the notes. So the latent space and their indication of whether they are a control or a test. Were they a matched control user who didn't actually receive a message, but we're going to pretend they did? Or were they a test user who actually got the message? You can then create model predictions based on that contingency. What's the prediction given all of the information that we had about what they received and what their baseline behaviors were? What's the likelihood that they were going to do the action that we cared about if they were a control user? That's your baseline. You then get a prediction for each user based on whether they were a test user. The difference between those two distributions is an estimate that you are influencing behavior. The target probability by itself, just the blue distribution, is the probability that they're actually going to do it. But if a user already has a 90% chance of doing it anyway, and giving them an actual message does not change that, you are running a risk in sending a message to that user without any measurable expectation of benefit. These weights end up giving these agents memory of a user's interactions. When we start with new users, this is the best timing action weight for a group of users for one app. You can see that for new users, everything starts about a 50-50. Your baseline probability of doing something is about the same as if you were messaged, because we're randomly messaging at this point. We're in the explore phase. So it starts learning a little bit. As users become more active and we get more information, you can see that the agents start getting very opinionated about what times are good for these individual users. Even when those users go into a fallow period, the agents still retain these scores. It takes a while for them to regress to the mean. So even when a user goes offline for a while, if they come back, or if they don't come back, for a period of time, the agent still can make reasonable guesses about how to bring them back and what their preferences are. If they go away for too long, then the agent says, I should just start over and flush all of my assumptions. This is from a delivery app that operates in the Gulf states. This was a test we ran with them on how well the system worked. So they were operating on a manual system. It's the biggest player in the field. It's one of those rules engines. And they had been using that for many years. They are power users of those manual tools. We randomly allocated a certain percentage of their users for them to continue being messaged through those manual processes, and then we randomly allocated another percentage to go with our process, the agentic process. And we also randomly allocated a small percentage to operate as a holdout control. So this was 9 different categories that we messaged about. The first time was over 8 weeks. And then for another 3 weeks, we added in hefty incentives into each of the messages, like 50 to 70% off messages. Even just each of these percentages is the percentage of users who engaged with the app after being sent a message within, I believe, 4 hours, maybe 12 hours. 12 hours. So you can see in most cases, the agentic process won in just a head-to-head comparison. But the really important point is actually this baseline rate, the middle 2 columns. Most of these manual tools, like I said, don't give you any idea of when you should message someone. And many of them have recognized this pain and actually have introduced, in fact, this tool, they call it intelligent timing. And their idea is, well, look for each user, look at when they're usually on the app, and then message them then. That's like hanging the sign on the bathroom door as someone's walking in. They were messaging them at the time when they were likely to be at the app anyway. But the reason they were messaging was because they wanted them to come to the app. And so they were actually sending huge numbers of messages to users who would have done the thing anyway. And for this last part, they were sending them 50 to 70% off sales. Promotion codes. They were paying users to do what the users were going to do anyway. So when you take those baselines into account and discount that, we ended up beating the manual process in every case except for one category in the second phase of the experiment where we were half a percentage point below. Another way to look at this is another company. They operate primarily in Singapore, a few other Southeast Asian countries. This was a little bit of a natural experiment. This was at the beginning of last year. There were some economic conditions that made the new VP of marketing nervous, and he told our contact that he didn't know what this AMP thing was. He wanted to shut it down. The contact contacted us and said, we're worried about that. We've moved a lot of our stuff over. Will you let us phase it out? We will take all of our triggered messages, our abandoned cart messages, things like that, and we're going to move those back over into using it in our manual system using the static rules. And can we just run that for a couple weeks and just see how it works? And you can see where they turned it off, and you can see where they texted us and said, we need it back on tomorrow. So the difference was enough that this guy's boss actually came to him and said, I will find the money for this because we can't afford the performance to drop off that much. So this is actually my favorite view of the value that an agentic system brings in. This is a company based in Boston. It's kind of like Uber for nurses. So hospitals put out shifts, and nurses are able to select what shifts they want to work in real time. So all of the blue dots at the bottom are messages that we sent. The gray wavy lines are periods of increased or lesser activity on the app. And then you can see several funnel events at the top. So they clicked a shift, they accepted it, or they actually completed it. And you can see this is one user, an individual user. You can see at the start they did a few things, and then they went away. So we messaged them a little bit. They didn't do anything. We messaged them again, didn't do anything. We started spacing out our messaging more because we didn't want to bug them. And after a while, we just kind of let them be for a couple weeks. And then we tried them again, and they didn't do much, but they did a little bit. And so then we waited a while, and then they came back on their own. We messaged them again, and then they converted. And then we waited, and then they converted again, and now we kicked in with a whole bunch of other things to follow up because now they were showing much more positive intent. No human made any of those decisions about content or timing or frequency of those messages. That was all based on the agent assessing when that individual user would be likely to respond and what they would be likely to respond to. There is no CRM team large enough to be able to do that for every user in an app. Also, there is no CRM team that even in their most drunken state would ever think this is a good idea. But this agent thought it was a good idea, and look at the conversion. This is my nightmare of a user experience, but there are users who respond to very, very different patterns. So the agentic approach to messaging is able to learn each of these different patterns for each user and actually present them with their own completely unique way of receiving communication with the app. And it's able to change over time as their preferences adapt. This particular nursing app looked at this and said, you know what, we spend a lot of money on SMS because push notifications are more or less free. They already have the app, it's just pushing it out. But an SMS costs. And we do use SMSs to fill last-minute shifts. And so they said, can we use this to reduce SMS costs? Because right now, we blast it out to everyone because that's what the tool allows us to do. But if we can differentiate it, so the only people who get blasts every time are the ones who respond to blasts every time, we were able to very marginally increase their conversions by sending 75% fewer SMSs. Cut their SMS budget by 75%. So every action in the system can act as a repository for user preferences. You can get that score for any arbitrary action you want. This is a number of value propositions. So you can see one user, more than anything, they emphasize convenience. Other ones emphasize the value of the product even if it's not convenient. This one below has actually several that none of them are very high, but it has, but there are multiple preferences. This can then be used to differentiate content, both in messaging and within the app. So same toaster, but you can change the title, you can change the paragraph about the toaster based on that individual user's preferences to get full differentiation. You can also, we're developing this for a customer, so it's not live yet. So this is prototype screenshots, but chatbots. This is a standard chatbot for an e-commerce system. So someone comes on, they're asking for a dress for a formal event. It starts asking questions. Do you have a color in mind? I said, I don't know, blue. And it says, well, what about length? Okay, I answer that. And then it says, okay, what about specific features? And I didn't really have anything. And it finally gives me several options. Now look at the words that it uses to describe the value of these dresses. Flattering fit, sophistication, romance, luxurious, rich, glamour. It's all related to the fact that I said it's a luxury event that this is for. Now, that's fine if you're going to a charity gala, but what if this is my 14-year-old daughter getting a dress for her like middle school formal? That doesn't quite speak to a 14-year-old. LLMs can take system prompts, a prompt the user doesn't see, but what is fed in on a per session basis. So you do not need to fine-tune or retrain the actual LLM. You can just feed it inside information for a particular user. So we fed it specific information that this person values most trend-setting products and fresh products, and their shopping experience, they like that to be effortless and personalized. And so then when we ran through the exact same chatbot, all the rest of the prompts stayed the same. I asked for a dress for a formal event. It said, sure. It mentioned trend-setting and fresh, which bugs me, but that's because I know what the keywords were, but the user wouldn't. And then says, can you give me any other details? I said, nope, maybe something in blue, like what I said before, and I get my answer right away. 3 follow-up questions to 1 question to get value, because I prefer an effortless experience. And if you look at what it's emphasizing, making a statement. It's going back to the preferences of trend-setting and fresh products. So we were able to get a better experience and a faster funnel just by feeding it in the weights that this customer gets for free by simply running the agentic model to do their messaging. I like this one. We work with a very large delivery app in India, and they have a robust data science team. They had 4 recommender systems. One was a standard collaborative filtering. Another one was looking at an individual user's history, trying to get what they personally tended to order the most. There were other ones based on kind of average popularity, things like that. And they could see the costs, and they could see benefits to each of them, but they didn't really know how to form these into a hybrid recommender system. Well, you don't need to only tag content. You can actually tag which recommender was feeding the recommendation to which message, and the agents are able to hybridize multiple data science products out of the box. We didn't plan on doing this. It was kind of an experiment to see if it would work, and it did. So you were able to find different users who preferred different kinds of recommendations. Not only were those users able to get recommendations that they preferred, but the data science team was also able to see the relative performance of each of their systems, find the worst performing one, and then start brainstorming about how they could improve that system. So you're able to take multiple data science products, and by tagging them in the messaging, you're able to start learning not only how well they perform, but what you can do next in terms of you're developing something. It's automatic deployment. It's not just automatic deployment, it's algorithmic deployment. So we've talked about productionization often, at least in data science teams I've talked to. Data scientists work on something and then it moves into production. And it's often this decision of, well, which one should we do? Like, which one is best? That's what a lot of the last talk was about. You don't need to choose a best one if you have a model that is determining which models to deploy for which users on a continuous basis. And this is something that a lot of the bigger companies have had for years. But like I said, this is for the companies that aren't engineering first. This is for the companies that have robust data science teams and engineering teams, but don't necessarily have the capability to build this out. There's no reason for this kind of system to have to be a bespoke thing. The agentic approach produces these results for, we've done gaming apps, we've done e-commerce apps, we do delivery apps, we do on-demand apps, streaming apps, things like that. It works across industries because it's a uniform architecture for making the decisions that fills in the human gaps that have existed in the data science productionization pipeline to date. I think that's all I have.